The next topic of discussion is the formation of domes, and we'll be talking at first about a dome that forms here in westernmost South Dakota. Taking a bit of a closer look, we're going to focus on this green patch here. This consists of a number of state and national parks and national monuments. Most famously, Badlands National Park here and here. Mount Rushmore National Monument here. Wind Cave National Park here. Most of you probably haven't heard of Wind Cave National Park. You may have heard of Deadwood, lead, and possibly spearfish and Sturgis. So Sturgis is where the bike rally is every year. Deadwood and lead are famous gold mining towns. You've probably heard of Wild Bill Hickok, Buffalo Bill, Calamity Jane. They were all regulars at a number of establishments here in these small towns. And spearfish was where I did my undergraduate field school. So this was one of my undergraduate mapping areas. The memories come streaming back. So this is kind of a super simplified depiction of what's going on. Essentially, the Black Hills are a crystalline, very old plug of rock that got punched up through Paleozoic sediment. So we can see those sedimentary layers punched up on the outer edge of this central uplift here. When I was an undergraduate, what we do is map these outcrops and then reconstruct the uplift of the Black Hills based on our mapping of various portions of this complex. The question is, why is it there? We have some nearly 2 million year old crystalline bedrock here that got punched up like squeezing a wet bar of soap between your fingers or a watermelon seed. It pushed up through the overlying rock that had been accumulating for hundreds of millions of years, and we get the Black Hills that we see today. So you can see the punch-up structure here and a bit of it here further to the northwest. What it looks like from the ground is here in the center of the uplift, we have the Needles portion of the Black Hills. Needles Highway runs through here. And nearby we have Mount Rushmore. So this is all carved in what's called the Harney Peak granite. It's about 1.9 billion years of age. It represents rock that was metamorphosed at about the same time the rocks up near La Ronge formed, and potentially in a related series of tectonic events. Now today, all these towns are tourist traps. I mean, like real tourist traps. Like you can't get away without spending money. What we have here is a map of a series of orogenic events, the Trans-Hudson origin, which is key to the formation of much of the Canadian Shield. And we see some other terrains getting glommed or accreted on to the former west coast of the North American continent. Part of this collision was the punch-up structure of the Black Hills. So we have a big wedge of crust, of lithosphere, crashing into early North America and producing this material here, which then got squeezed up about 80 to 60 million years ago. Now it's famous for this guy. This is General George Armstrong Custer. He's a fellow Ohioan, though we grew up on different sides of the state. He graduated last in his class at West Point in 1861. Fortunately for him, the U.S. had declined into civil war, and they needed people to lead their various armies. So he got promoted to general at the age of 23. In spite of being the worst student in his class, he ended up going to Gettysburg, and that was one of the seminal battles of the American Civil War. He was known for being brave, which could also be considered to be stupid today, and he was lucky. So he was present at the signing of the treaty between Ulysses S. Grant and Robert E. Lee that directed the Army of the North and the Confederates. This ended the Civil War. So now he's out of work, mostly. So he gets sent to fight with the Native Americans that had been displaced to the west. He's sent to the west after the Black Hills were given to the Sioux as a reservation, as a reserve, as you call it in Canada. Shortly after that, gold was discovered there. And then, of course, in American history, all bets are off. So they send Custer and his troops to the west to quell the issues between the Sioux Indians and the colonists that were violating the treaty by mining for gold, and it didn't work out so well. He went on a deer hunt with a number of his troops. They ended up getting surrounded, and he was killed along with all of his men. Almost every single one of the U.S. soldiers was killed in this battle of Little Bighorn. You can see here, this is the hill that they died on. The last remaining U.S. military died on this hill, and you can see the number of others that were killed in the battle are here. The Sioux were not buried by the U.S. government. They were mostly recovered and moved elsewhere. The people that were here were disinterred and moved, at least most of them, down to this lower area. Today, we have the building of the Crazy Horse Monument. Now it looked pretty similar when I was a little kid, so I wouldn't hold out a lot of hope that it's going to look like this anytime soon, but they're working on it. So this is a monument dedicated to the Lakota Sioux chief, Crazy Horse, that defeated Custer and the U.S. Army. Now, when we talk about the tectonics of North America, it's important that we have a discussion of the Appalachian Fold Belt. It represents a large portion of eastern North America, particularly in the United States, and it was active. It was forming between 470 million years ago and about 270 million years ago. So it's a very long history, a complicated history. The Valley and Ridge Province that we'll see in a moment has episodes at 470, from 380 to 360, from 320 to 270 million years ago. The Blue Ridge Province is composed of Precambrian and Metamorphose rocks that are pushed on top of younger sedimentary rocks. This occurred at about 300 million years ago. And these Precambrian and Metamorphose rocks are harder than the younger sedimentary rocks, so this is why we have a resistant ridge that has the Blue Ridge Parkway, the highway, running right along the top of it. The Piedmont consists of metamorphosed Precambrian and Paleozoic rocks that are sporadically intruded by granites and then pushed over top of the Blue Ridge rocks in the northeast. That has been eroded since then. We have the coastal plain. This is relatively undisturbed sedimentary rock that started accumulating about 180 million years ago. Once things got quiet in the Appalachian Fold Belt, the sediment that was shed to the east and west, and to the east, that sediment accumulated on this coastal plain. So here we can see that in cross-section. We have the continental plateau truncated by the valley and ridge. It's called the valley and ridge because it consists of ridges and valleys that are often related to the lithology. So resistant rocks are going to tend to stick up, and easily weathered rocks are going to weather away. As we move to the east, we hit the Blue Ridge, which are metamorphic rocks, very hard crystalline, ancient crystalline rock that got pushed up on younger sedimentary sequences. So they're resistant to weathering, and they remain as positive relief to this day. The Piedmont is off to the east, relatively high compared to the coastal plain. And then off the coast, we have the continental shelf. Here it says reef complex. That is the case only in southern Florida. And in False Collar Satellite, we can see a lot of the structure here. What you'll notice principally in this image is this long, sinuous band of deformed rocks that has the shape of the suture between North America and Gondwanaland, which was Africa at the time. Well, largely Africa at the time. Here we have our cross-section that we just looked at, A to A prime. This is a common way of indicating a cross-section on a geologic map, in this case a surface map that's going to be converted to a geologic map. This Alleghanian orogeny that formed these contorted rocks occurred principally from around 325 million years ago to 260 million years ago, and consisted of at least 5 deformation events. So 5 collision events that resulted in structural deformation and or metamorphism. So this orogeny was caused by Africa colliding with North America. And at this time, there wasn't a North American continent. There wasn't an African continent. North America was part of the Euro-American supercontinent, while Africa was part of Gondwana land. And the collision formed the supercontinent Pangaea, which was made up of all major continental land masses at that time. So Pangaea, the whole Earth, all the continents were mashed together during that period. What you can see here is that A to A prime cross-section going from West Virginia to Chesapeake Bay. We're cutting across the Ridgeon Valley, again called the Ridgeon Valley because of these ridges that envelop valleys. This was a problem for the Northern Army in that the Confederates knew where the gaps were. These gaps are very, very old rivers that have persisted in spite of the rocks that they're weathering today being uplifted. So the river existed, then the collision took place, rocks were uplifted, the river cut down through the rocks as they were uplifted, forming these gaps. The Cumberland Water Gap is one, the Delaware Water Gap is another, located up here somewhere. Very spectacular to drive through, by the way. So the Confederates would appear in one valley, the Union would watch them from the ridges, and then they'd be gone. That's because they squeaked through this gap and then moved on to another valley, maybe overnight, maybe during the day. But it remained a mystery, and that was one of the reasons that the war lasted as long as it did. Here's another example, maybe a little better for showing the Ridgeon Valley development. This is southeastern Pennsylvania. So the capital, Harrisburg, is located over here. Another false colored image here, again showing the structure of this series of deformational events. A little further to the north, we have New York City. So Statue of Liberty here. We have Manhattan here. Central Park is located in here. Then you have the 5 boroughs around Brooklyn, Queens, etc. Looking from Battery Park, which is located here. The former Twin Towers of the World Trade Center were located right here. This is their footprint. And you'll notice that the buildings here are very tall and the buildings here are very small. This is because of geology. These buildings are on a very firm, very stable, metamorphic basement. Very old rock. The rock here, much younger, can't support the weight that this metamorphic gneiss can support. Continuing on our magical mystery tour of the tectonics of North America, we'll again talk about the geology and in some cases throw a little bit of American history and Mexican history into the mix, just to give you a feel for how geology influences human society. So we'll be talking about the North American Cordillera. This ranges from Alaska to Guatemala. Again, Guatemala is part of North America. That is to say, part of Guatemala is part of North America. The rest of Guatemala is part of Central America. So we'll take a look at that. And this will be a story of uplift and orogeny, rejuvenation of crust, and crustal stretching. What happens when we heat the crust from below and cause it to expand like a out-of-control muffin. We'll start out here in the north, in Alaska. There's a highway that runs from Prudhoe Bay here on the north slope all the way down to the southern tip of South America in Ushuaia. We're going to take our road trip here to start. This is formerly known as Mount McKinley. The mountain is now known as Denali. It's in the Alaska range, and you can see it maybe a little more clearly here. So the Alaska range transitions from the Aleutian Range into the Wrangell and St. Elias Range over here, and the Chugach Mountains. So a very rugged part of North America. It's now known as Denali. It was called Mount McKinley for about 100 years. McKinley was a president that was born in my hometown, and he was a big proponent of the gold standard. So in the late 1800s, the gold rush in Alaska and the Yukon led to a push for money to be based on the gold standard. So one of McKinley's fans said, hey, we should name the highest mountain in North America after President McKinley. And then McKinley was assassinated. So this Alaska range was made famous in the movie Into the Wild, story of a rich kid from the southeastern U.S. who decided he would get back to nature, and it killed him because he wasn't ready to get back to nature. This is a Dall sheep and grizzly bear, two of the characteristic animals of this Alaska range. And here's an image. So we have the Alaska range beginning here. Denali is located here in the clouds. It is a little over 20,000 feet in elevation, and that's about 6,190 meters or so. So again, the highest point in North America. Now, Russia had claimed ownership over Alaska for about 70 years. From 1799 to 1867, they maintained control over that area. Looking for some quick cash, the Russians offered up Alaska to the Americans, and the Americans took it. William Seward, who was Secretary of State under Abraham Lincoln, who was nearly killed during the Lincoln assassination attempt when a guy named Powell broke into his room and ended up severely injuring 8 people, including Seward, who was stabbed in the face and the neck. Fortunately for Seward, he was recovering from a carriage accident and had a splint around his neck, and that kept the knife from cutting the artery leading to his brain. So Seward survived. The other people that were stabbed survived as well. And he offered the Russians a check for $7 million, which they accepted. Everyone laughed at him. It was called Seward's Folly, Seward's Icebox. Big mistake in 1867. In 1897, when gold was discovered, no one was complaining anymore. Seward became a hero, as much as a former Secretary of State can become a hero. We're going to then jump south to Mexico. We're going to temporarily skip over the western U.S. We're going to come back to that. We're going to skip south to the Sierra Madre Occidental. We're doing some bat research in a place that is not on this map, not too far from Hermosillo, about an hour from Hermosillo out in the desert. So what we're going to look at in the next few images are the mountain range that forms the Sierra Madre, and then the canyon that's located down here, Barrancas del Cobre. And there's a little 3D version of the same map here. So we're looking at this mountain range here. The mountain range over here has the same name. We're not going to go over here for now. So it's mostly in the state of Chihuahua, which is a really nice part of Mexico, really high altitude, cool temperatures, always sunny, no beaches. Perfect. And here's an image taken just around sundown from the highway, which is known for robberies. So the general tactic is you throw some railroad ties or a tree in the road, and when you stop to move it, they take your stuff from you. So again, a beautiful high altitude part of the world, nice and cool. This is Barrancas del Cobre, Copper Canyon. It's reminiscent of the Grand Canyon in Arizona in the U.S., and it's got some similarities. It's a pretty sizable canyon. There's actually a race. The native population runs barefoot through these canyons that last for days, and the prize is that you win. This is El Mirador Temple Huehuetenango. So what you can see here is a former student of mine, Matt Lockneat. He's now the head of the geology department at the University of Nevada, Las Vegas. We're standing at the edge of the abyss from the Guatemalan highlands into the Mexican lowlands. So off in the distance here, you can see the mountains of Mexico, the Sierra Madre Occidental, back here, and to a lesser degree over here. This is a view of the sedimentary sequence that's below our feet in that last image. A thick sequence of carbonate rock. And now we're going to take a closer look at the North American Cordillera. Again, this is going to be a story of uplift and orogeny, rejuvenation, and crustal stretching. Starting up first, we're going to go to the Coast Range. We're going to take a look at Crescent Lake, which is up here on Vancouver Island, and then the Gold Coast, which is down around here somewhere. And then we're going to get to the Sierra Nevada range, which is located here. And we'll take a look at Yosemite at that point. So here we have the coastal range in BC. This is very similar to what you see in Oregon and Washington, located just a little bit to the south. This is the Oregon coast. Best grilled cheese ever, somewhere over here. Sourdough bread, giant fries. And down into the Sierra Nevada, this is a batholith, a felsic granite batholith. And the next image is going to be taken from around the corner here. This is El Capitan. You're maybe using an operating system on your Mac named after this. Behind this mountain, behind this cliff face, is going to be the next location. And we're going to be looking in this direction towards Half Dome, which is here, the feature that looks like half a dome. Hey, here it is, Half Dome. So from the other direction, looking back into Yosemite Valley, what we can see here is what's typical of granite weathering or granitic weathering. We're going to get back to this when we cover weathering in a subsequent chapter, but for the time being, again, very light colored, felsic rock, emplaced as a batholith, slowly cooled, large crystals, the whole shebang.